let's pretend that I have a problem to resolve. For example, how many grams of iron oxide will be obtained by burning 10 grams of iron. What are we going to do? First, we are going to write down the question in the form of a fraction, the same thing that we did before. So which is my question? How many grams, x then in grams, of iron oxide, so I'm going to put here which is the iron 2 oxygen 3, are going to be obtained with what? With 10 grams of iron metal. So we are going to do exactly the same that we did before. We are going to make a equal sign. You draw a line, and we are going to put here the same units, grams of iron oxide and grams of iron here. Yes? Once we have that, what we are going to do is to use the numbers that we obtain here in the reaction, because those are going to be the ones that give us the ratios. Do you understand what I'm doing? So grams of iron oxide, I forgot a 3 here, are 320. Do you follow me? And grams of iron are 224 grams. Okay? So now the only thing that we need to do is, as always, take this and multiply, and because do you remember that we said that whoever is in this diagonal is multiplying, and we divide by 224, and we are going to have the value. So again, x is equals to, and we can simplify grams of iron and grams of iron here. Okay? So x is going to be 3200 because it's multiplied by 10 divided by 224, and the units, guys, is grams of iron 3 oxide. Yes? Now, when you have to resolve the problem, you are going to have, again, as always, 4 points. Okay? So, for making the calculations of the molar masses, it's going to be 1 point. For putting the work with units, 1 point. Getting this number correct, which, Kate, you did a calculation? 1429. So if you put 1429 only without showing anything else, you're going to get 1 point out of 4. Okay? And if you put the units here, those units, you're going to get another point. Yes? Now, let's say that instead of this one, we need to calculate moles of instead of grams. Can we do that? Yes. Why? Because here we have the amount of moles that react. So instead of putting 96 grams for oxygen, we can put 3 moles. So let's say that instead of how many grams of iron 3 oxide will be obtained by burning 3 grams of iron metal, they said how many grams of iron oxide will be obtained burning 10 moles of metal. The thing is going to be the same. okay, I'm going to put how many grams, in grams, it's very important that you put the unit, of iron 2 oxide will be obtained. Instead of grams here, I'm going to put moles. So if I do this with moles, I'm going to do it with another color, so you have it there too. So instead of 10 grams, I would put 10 moles. Okay, if they are asking me for 10 moles, how much iron oxide I'm going to obtain with 10 moles. Now, it says how many grams and 10 moles. There are two different units. Can we mix and match the units? Yes, because it's the same as saying 12 or 1 dozen. Okay, they are equivalent. So I can talk about the moles or about the grams individually. So the numbers that I get from the equation now are going to be 320, because we have grams here, because we need grams. Is that okay? Now, instead of 224 grams, what would you put there? Exactly, 4, because 4 are the moles that are here. Instead of this number, 224, you are going to put 4 moles. Okay? The math is exactly the same. So what I'm going to do now is to give you some exercises that are already in the webpage, and you are going to